Hello, and welcome to the internal workings of the Java compiler. The Java compiler is a program that converts Java source code into bytecode. The bytecode is then executed by the Java Virtual Machine JVM. When you compile a Java program, the Java compiler performs several steps. First, it reads the source code and checks it for syntax errors. If there are no syntax errors, the compiler generates an abstract syntax tree AST for the program. Next, the compiler performs semantic analysis on the AST. This involves checking the types of expressions and ensuring that they are used correctly. For example, the compiler will check that you are not trying to add a string to an integer. Once the semantic analysis is complete, the compiler generates the bytecode for the program. The bytecode is a low-level representation of the program that can be executed by the JVM. The Java compiler is a complex program that performs many optimizations to generate efficient bytecode. For example, the compiler will inline methods, eliminate dead code, and perform constant folding. In addition to these optimizations, the Java compiler also performs several other tasks. For example, the compiler will generate debugging information that can be used to diagnose problems in the program. The compiler will also generate class files that can be used to distribute the program. The Java compiler is a powerful tool that is essential for developing Java programs. By understanding how the compiler works, you can write better Java code and optimize your programs for performance. Java Virtual Machine. The Java Virtual Machine JVM is a specification that provides a runtime environment for Java bytecode execution. The JVM is responsible for interpreting the bytecode and executing it on the underlying hardware. The JVM is a complex program that consists of several components, including the class loader, memory area, execution engine, and register set1. When you run a Java program, the JVM performs several steps. First, it loads the class files into memory using the class loader. Next, the JVM allocates memory for the program in the memory area. The memory area is divided into several regions, including the heap, stack, and method area. Once the program is loaded into memory, the JVM executes the bytecode using the execution engine. The execution engine is responsible for interpreting the bytecode and executing it on the underlying hardware. The execution engine uses a register set to store intermediate values during the execution of the program. The JVM also performs several optimizations to improve the performance of the program. For example, the JVM will compile frequently executed code into native machine code to improve its performance. The JVM also performs garbage collection to free up memory that is no longer being used by the program. That's a brief overview of how the Java Virtual Machine works. I hope you found it informative.